Hello everyone, today we have a hard question, minimum cost to hire K workers. We will be solving this problem using a max heap or a priority queue. You are given two arrays, quality and wage, which contains the quality and the minimum wage of each worker, and we have to choose them in such a way that we pay them the minimum cost. And the paying has some rules. The first rule is that the worker should be paid at least their minimum wage, okay? The second is that each worker's pay must be directly proportional to their quality. What does this mean is that if the quality is 10 and you are paying the workers, let's say 100 rupees, then if the quality of another worker is 20, then you should pay him 200 rupees because the quality is doubled. Let's take this example. Here we have k equals to 2 and the quality and wage array. So, if we are going to pay them according to their proportion, let's say we have R. What is R? R is a rate per quality that you are giving. And why is that? Because we have to maintain proportions. So, if we have like say a number that we pay per quality, then we can calculate for every quality. If we can just multiply the quality with that rate and we will get the proportional price that we are paying to the worker. We need to ensure that this quality, any quality Q from the quality array multiplied by R that we are choosing, the quality that we are choosing of any worker, that should be lesser, that should be at least its wage. It cannot be lower than that because we have to maintain the minimum wage. Now the question is, what should be this rate? We can calculate the rate or the ratio of wage per quality for each of the worker. If we look at R, let's say for this 0th index, we can calculate it by 70 by 10, that would be 7. And then for the first index, that would be 50 by 20, that is 2.5. And for this second index, we will have 30 by 5, that is 6. What does this means is that if you are selecting this worker as a base, like you are paying it according to its minimum wage only. Why we are doing this? Because we want to select the minimum cost. So if we fix a worker and take its rate, then we will calculate it for rest of the workers. Okay, so what I'm saying is, let's say we select the 0th worker. Okay, so if we have 3 workers, so our rate R1 now let's say is 7. So we are having first case where we choose the rate of this first worker. Then what are the pays that you have to that is what are the prices that you have to pay to other workers? For this 0th worker, you will have to pay only 70 because that's its rate only, and also if you multiply it 7 by the quality, because this rate is nothing but the wage per quality. Okay, that is wage per quality. So that would be 70. Now, this 20 multiplied by 7, that would be 140. And this 7 multiplied by 5 would be 35. And now you have to select 2 workers because our K is 2. So what is the minimum of them? So that would be 35, the minimum, plus second minimum, that is 70. Okay, so that would be 105. And now let's take next rate. So our next rate will be R2, and let R2 is 2.5. So for this worker 0, you will be paying 25. And for 2, it will be just 50. And for this, it would be 12.5. But what is the problem? That you can take this worker that will be 50, but you cannot take them because we have the condition 1 that we have to pay them at least the minimum wage. And this is lesser than the minimum wage, and similarly this is also minimum wage, that is, it is less than 30. So now let's take R3. R3 is 6. So worker 1, it will be 60. And now as you can see, this is less than its minimum wage of 70. So we cannot afford him. So we cannot take this worker. Now let's take different workers. So for 20, the first index, it would be 120, and for 5, it will be 30. And this will give us 150. And now you have this as a valid price and this as valid for selecting 2 workers. So what you found is that this is minimum. This is the minimum price that you have to pay to hire 2 workers. And why is this minimum? Because we have to select this R from these only, from these rates only. Because if you take lesser than 7, you will not be able to afford this worker. Okay. And for greater than this 7, you will always be paying more wage than required, because that would be more than 70 also. So one way that we identify is that we can calculate these rates for each of the worker, and after calculating the rate for each of the worker, we can again traverse the whole array and see if we can afford the worker. Then we will take it, and while taking it, we will see if we can take k workers such that we are paying the minimum wage. Okay, and then we will have to do this for each of the ratio. For each of the ratio, that would be n ratios, and for n ratios, you will be comparing all the n workers, that if we can take them or not. And if we can take them, then you will have to take the minimum of the answer. So that would be O of n square. That would be O of n square. But that wouldn't be permitted because our constraints are that n is 10 to the power 4. So that will be 10 to the power 8 operations. So that will give us time limit exceeded. That is why it's a hard question. So we need to optimize it. How are we going to optimize this? Using a heap. I wasn't able to solve this question myself within this time constraint. So I have taken reference from this solution. You can check out in the description. We can solve this question in just 3 steps. The steps or the coding part of this problem is kind of simple, but to understand it, it's a little tricky. So we look at the first step. That's nothing but to sort the array. Step 1. How are we going to sort it? We are going to sort our array according to the ratio that we calculated, that R. And what was that? That was wages of I divided by the quality of I. Quality of I. Now, if we want to do that, we have to make another vector for it. That would be vector of pairs, which will contain the wage and quality of the indices. So that would be like, we will make pairs such as, let's take the input first. So first we will make the vector. So the vector would be 10, 70, that's quality, wage. And then it would be 20, 50, and then 5, 30. Now you can make a custom comparator and sort this vector according to the ratio, and that would be a little difficult because you will need the ratio later. So instead what we'll do is, instead of making this vector, we will make a vector which will contain pair only, but first would be the ratio and second would be just the index of that entry in the original array. That is these arrays entries. So how are we going to do it? We will make the first vector will traverse from here, and then the first ratio is 7 and the index is 0 for that worker. For second one, it is 2.5 and the index is 1, and then we have 6 and the index is 2. And now as we have gotten this, we will sort this according to the ratio. So you don't need to make a custom comparator for this purpose. You will just sort it and it will be sorted based on the first value automatically. So that would be giving us 2.5 and its index is 1, then 6, and then finally 7, 0. So that's the final vector after sorting that we have according to the ratios. And if we want to access the quality or wage of any worker, we can do that by this index. Now, the step 2 is to make a heap. This will be a max heap that will contain the quality of the people or the worker that we are pushing into. You will understand it in a bit why are we doing that. So what we will do is we will traverse this array from left hand side. So that would be traversing it from the minimum ratio. So that would be minimum wage per quality ratio worker that we will insert in the heap. And how many workers are we going to push are just k workers. We will push first k workers such that their ratio is minimum. So if this is our heap, so first we will insert the first two entries. So that would be 2.5, 1 and 6, 2. But we are not pushing these values. Okay, we are going to push the quality. So for this worker, we will look at this index for the quality. So that would be 20. And then for the second worker, the quality would be at index 2. So that would be 5. So 20, 5. These are the entries of our heap. Okay, this I have drawn just to make you understand. Now, this is our heap. And now, we move to the step 3. The step 3 is the most important part. Now, let's try to understand what should be the price up till now that you have inserted in the heap. How can we calculate it is by the quality, that is the total quality that we have right now, multiply it by the maximum ratio. Maximum ratio, that means for all the workers that you have pushed that are present in the heap, the maximum quality of those workers. So if we look at the heap, we are just pushing the quality, but while pushing the elements, we have this vector which can give us all the quality and the ratio that we want. So while pushing it, we will maintain the variable to calculate the total quality that you have pushed in. So while pushing in, we will have, let's say, quality sum. So the quality sum, while pushing it, we will make 25 because we have pushed 20 and 5. And the second thing will be the maximum ratio. Now the maximum ratio would be the last element that you have pushed. And why is that? Because you have sorted the array according to the ratio. So the maximum ratio would be of this one, and that's 6. So the maximum ratio is 6. And now, how we did was the wages to be paid are in proportions. And the maximum ratio is what we are choosing right now, because for the maximum ratio, if you select that one, all the other wages will have lower ratios. So if you multiply their quality by this maximum ratio, you will automatically get a price which is greater than their minimum wage. So the step 1 or the condition 1 would always be satisfied. Okay. So right now, our result or the amount to be paid to the workers would be 6 multiplied by 25. That would be 150. But we saw in the example, this is not the minimum sum. And if we look closely, we have this entry left. So how are we going to proceed is, we will traverse the remaining array right now. Okay. We will traverse the remaining array, and we will obviously are going to get an entry which has a higher maximum ratio. And if you look closely, how we were getting the answer was this quality multiplied by our maximum ratio. And if this maximum ratio is going to increase, then for the overall sum to decrease, we must decrease this quality. This quality must be decreased. And how are we going to decrease this quality? That is possible because if you look into this example, what we are having is that this first index has a quality 20. It is giving us the lower ratio. Okay, it is giving us the lower ratio, but we don't consider that because we have to consider the maximum ratio, that's 6. And then we are going to pay this in proportion of this ratio only. So it is going to be paid 120 because it has quality 20. And now if we include this one, 0th index one, we will have to pay according to this one because it has a greater ratio according to 7, but it has lower quality. That is, it has just 10 qualities. And for that reason alone, we are decreasing the quality even though the ratio has increased. Okay, even though the maximum ratio has increased from 6 to 7, but the quality has decreased by much extent, and thus the overall sum will decrease. So what we are going to do is, for the rest of this array, we will traverse this, and when we get this one, it has the higher ratio of 7. We know that. So now our max ratio will be set to 7. It is not 6, it's set to 7. And now our quality sum, it's to be decreased, but you have to select 2 workers, so you will have to remove 1. Now which one do you think we should remove? We have to decrease the quality, so we must remove the worker which has the high quality number, and in that case that is 20. And now it must click you why we are using here a priority queue, because we know that we have make a max heap. This is nothing but a max heap, and we are pushing just the quality. Why quality? Because now you can get this 20. You will get this 20 out. It will be the maximum quality, and from this quality sum, that's why we have maintained this quality sum. You will need to subtract this quality because you are removing that worker because it had the maximum quality, and we need to lower the quality because our max rate is going to increase. So now from this quality sum, you will subtract 20, or I should say you will subtract what this heap top will give you, and now you are left with 5. And now you will include this worker, and it has a quality of 10. So your new quality sum will be 5 plus 10. That's the quality of the current worker that we are including. So this will be 15. So our total quality sum will be 15 now, and our max rate would now be 7. And if you multiply them, because this is finally going to be our amount, the amount would be 7 multiplied by 15, and that would be 105. And that is the minimum answer. Okay. So if you haven't understand this, you can take a bigger example. And I hope that you have understood this video. If you want to have the code, it is attached in the description. Also, I've given the GitHub link as well as the LeetCode link. And if you have any doubts or you have a better solution to this problem, you are welcome in the comments. Okay, so thank you. Bye bye.